Welcome to the second Another Peak Clearblade webinar session with myself, Chris Reed, and our special guest, Aaron Alsbrook, CTO of Clearblade. Today's topic is image recognition, a topic Another Peak have done considerable amount of work with over the years. 3 years ago, at the time, Another Peak were heavily involved in the SD-WAN wave. So the question was, could we use that technology to manage the crossings? Now, SD-WAN is great at application prioritization. I can identify camera flows and give them a preference back to the control center. But we encountered bandwidth capacity problems. And also, if the backhaul went down, we had absolutely nothing. Fast forward 12 months to smart retail. This is more important today as traditional retailers search for ways to entice visitors back into the store. But then the idea was to use cloud-based facial recognition to identify premier customers and reflect this back to handheld devices in store used by the operators. The combination of bandwidth and the transit time to the cloud was an issue. But more importantly, in those days, compliance was a major concern. Folks didn't want their images sent randomly around the internet. And today we find ourselves in the COVID era. The challenge of joining up separate data flows. Take a shopping complex. I want to monitor people flow via CCTV. But also say elevator failure, because if one fails, I need to update the security staff in real time and offer advice. But also interact with digital signage to inform shoppers of key issues. I need a platform capable of aggregating all these feeds, giving the operational folks true visibility. And that's why we turned to Clearblade. So if I stop sharing and I hand over that to Aaron, if you would like to continue.
You bet. No, thank you, Chris. That was a great setup, and I'll do my best to pick that up. You really have painted a pretty good reason why edge computing actually matters so much, right? We are inundated with edge computing today from commercials and lots of opportunities and articles, but finding really those good pain points that edge computing can actually solve is a little trickier, and you just painted three really good ones there of the bandwidth constraints, the privacy issues, the ability to integrate right at the location. All of those are things where edge computing solves, and really Clearblade's right in the middle of that story and building these solutions like you just talked about. I kind of wanted to set the stage a little bit, Chris, if it's okay, and just talk about how image recognition works or video monitoring works at the AI, at the technical level. Is that a good place to begin?
Yeah, that's a great place to begin, Aaron.
Okay. So I'm using the words edge, I'm using the words IoT. Those are the cool new words, but let's just think about the bottom as four different locations on this slide, four different hallways, so to speak. If you had these four different hallways, you could put an edge computer, a gateway computer, a little device that has Intel or ARM chip on it, and you could begin doing edge computing at that location. So we could put in our hallway the edge computing, and then we'd go get a camera, and we could run that camera feed into that little gateway device, and we could begin doing AI. But we're not doing AI right away. The first thing is what are we going to do with the data that we have, and how do we even understand it? Right. Images happen to be something that are pretty common. Lots and lots of use cases want to know objects, want to know where people are. So we have seen AI, at least for human detection, really advance in the ecosystem, and that's why we can bring it in so rapidly. Certainly there's lots of other AI algorithms that get very more specific. But what has to happen is we have to begin getting that data. In the case of images, it's video feeds. So we have to gather the data, we have to connect to the camera, we have to then secure the information. We don't want anyone to be able to get this. We've heard horror stories of cameras on the internet, right? And then we have to securely bring that data. So you see on the bottom, we take from one hallway, we might be just wanting to watch people, we send that data up, we say IoT platform, It's a server, right? It's running in the cloud. It's just running on somebody's hardware, IT. The IoT platform gets that data. Maybe it structures it. Maybe it combines it with other information it might know, but we actually give it to data scientists. Now, again, AI algorithms for people detection are pretty well mature, so we don't really have to do a lot of work. But everything requires taking some work, and you send it to your data scientist where they go through really what I call those 5 steps of actually building a predictive model. They take the data, they clean it up, right? They restructure it. We might have just sent them some basic stuff, but they might want to change some features and attributes, standardize things, throw out anomalies so they have a good, clean data set. Then they look at it and run some algorithms. They have lots of algorithms to choose from, over 20 algorithms to choose from. They're not new, right? These are algorithms that started getting discovered in the 70s, 80s, and 90s, right? But now they can run at scale. So they go through, and ultimately when they're all said and done, they have a model. And they test that model. They use some other footage that wasn't used to train to test that model and make sure, aha, it works well. It can identify people walking down a hallway. Once you have that model, you can predict, I see people. You now want to take that model and move it all the way back down next to that camera, right? To your point, Chris, you don't want everybody in the world to see the camera stream of the faces or the people or whatever else, right? Whatever else is going on. It's private information. We move that model back down to that camera, right next to that camera, then the data never flies anywhere, right? All we get is person, 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 not a person, not a person, right? We're able to obfuscate or protect or whatever it needs to be. We're able to do that because we move that model and run it back down on that little gateway, Raspberry Pi, whatever we've picked to run down there. So that's how, when we talk about, why is Clearblade an edge company in this conversation about image recognition, is the fact that, AI needs edge computing. AI is incredibly valuable when it has edge computing. And quite frankly, edge needs great algorithms to make itself more valuable to do more. So they really go hand in hand. And we partner with a lot of great AI companies from the big guys, using TensorFlow in the cloud, all the way down to some very specific ones who understand exactly, what pressures to drill through certain types of soil densities. But ultimately, the pattern is the same. Give somebody a lot of data. Let somebody with real expertise who understands the problem do their job. Often that's our customers or our partners that understand their data. I really don't know. I mean, I've learned a lot about different industries, but how do you predict when a switch on a railroad crossing is going to go bad? Well, there's a lot of voltages and currents, and you can watch these things go over time, but predicting it, that's not my domain expertise. I really have never even owned a railroad switch, to be honest with you, Chris. Imagine that. The same is true of lots of things. How do you predict arrival? You look at these algorithms we use when we drive around, predicting that you're going to get to some city from here if I leave at this time on a Tuesday, right? These are all just big, big patterns that we've gathered and built models from based upon the fact that we have so much data. But we want to bring it back to the edge and then protect privacy. Want to be fast, right? And think about when you're driving along on a highway and a picture is taken of your license plate. Do you think they want to pay to send that image all the way up over the network back to the cloud to know what your license plate is? They'd much rather, it's much more efficient to process that image there. So that's the technology. But then the technology is just nerds speaking. No offense to ourselves here, Chris. That's just nerds speaking. Right. The reality is what are we trying to apply? What are we trying to do with this? And AI analytics, right? We can use these terms a little bit kind of interchangeably for the moment, because certainly we can use analytics to drive some of this stuff. But AI is big for this, right? We've taken our data, we've generated AI models, and then we can look specifically at what's going on. Let's just take a facility. Facilities, we're very aware right now at this moment in time about what's going on in large complexes, especially with people, right? It's part of public safety. It's part of us really getting through what is a difficult time here for everyone in the world. Let's just think about what we could know anonymously, right? We're not going to ruin people's privacy, but at an operational level, if we can just know when people walk down a hallway, we essentially know we're going from A to B, building A to building B. Provided we know every entrance and exit to B, we're going to have a real-time number of what that occupancy is, right? So that's pretty interesting, right? We now know, I mean, think about everything we've ever seen, occupancy for fire codes, everything else, buildings for school. They're not sitting down and saying, you know, yes, it'll be great to know exactly 6 feet, but they start with 25% occupancy as their target, or 50% occupancy. Cameras do this. Image recognition does this. Quite frankly, it does it almost out of the box. Now, you'll notice there is some data science in this because camera angles change, right? The hallways, how dark the hallways are, change. You might put a mirror up and suddenly there's 2 people and then there's 1 person, right? So you got to teach the model just a little bit about the nuances of the environment, or let the model learn about the nuances of the environment.
Right.
But in general, we can take this technology and drop it in. And now we suddenly know how full the building is. We know if we're over, right now we can do our standard kind of almost if-then logic, over, under capacity, who do we alert? We have the ability to see where people are at. There's something called stitching where we're really putting this together. I see Chris walk by from A to B, and then I notice that there's a guy, it's still in a blue sweater, right, at point C, and I put you back together in the life cycle.
Right.
There's value there too, right? And that's on the next one of what your behavior is. But just with this, we can begin understanding what's working. Another interesting thing is you notice that there's a picture there of an escalator. Right? All the algorithm is looking for is, are people going up and down the escalator? But the reality is, if I quit seeing people come up that escalator, something's wrong. Probably, especially if it's out of normal for what we see during that time of day, the escalator's broken. Right now, we might see 1 person climb the old-fashioned stairs, but we actually can use an algorithm that recognizes only people to identify what's going on with our existing other systems out there. All of this is to say, though, the edge computing isn't done. As a matter of fact, there's really not a ton of value if you can't integrate this information to other systems, right? We can present it, obviously, and tell someone, a management, what's going on. But really the next step is, how do we integrate this? We see people, we turn on the lights. There's energy savings. We see escalators that aren't moving people. Escalators are broken. Alert someone. Get it fixed. Tying these systems together to, what we started with was just a cool algorithm of how do we recognize a person, can really begin to change what we do. I'll hit 2 more kind of environments where we're applying these different sort of operational analytics.
Okay.
Behavior, customers, we are going to get through this time, and we're going to go back to how do we better have better experiences for our customers. Understanding where they're sitting, understanding where they're standing, the dwell time. It's really interesting. If you think about what's happened, we actually started calculating dwell time on web pages, 15 years ago, right? The big retail websites were watching where my mouse moved to see where my eyes were going, right? They were doing all this. We're now finding we can bring this back in. Again, quite frankly, with more privacy than any of the internet solutions and web solutions have offered us, thanks to edge computing. But now we see where people go. Here's how, they're spending a lot of time at this particular location. We recognize when they're coming into our stores. We can even see things that were less desirable, like theft, or maybe breaking of our product. And yet again, it's one thing to know it, but integrating with the other systems gets very powerful. You think about a customer and sitting in a certain location, how do we service them faster? You think about someone on a rail platform who's laying down. That's not something we want to have happen. We need to either find out, is there a medical need, or do we need to get them out of there? So there's a lot of different things that can happen just by serving these customers, whether it's in a retail environment, whether it's in a public forum environment. There's things that we want to be able to do. The last one we talk about analytics being applied is really about kind of the efficiency of it all, right? So a lot of people, whether they're our customers or our partners or our citizens, are getting an experience in our environments. We can take these analytics, again, very simple analytics. A person moved A to B, a person standing still, not moving. we can take this and begin to recognize certain patterns. You'll notice there in the image, there's a little bit of an orange square. This is a person that walked forward, walked back, walked forward, walked back. That's confusion, right?
Right.
And
yeah.
as someone who's tried to get on a train before, I've been very confused, right? I don't want to get on the wrong one, right? And oddly enough, I watched this person. They didn't see the big screen. There was obviously digital signage right here. They never saw it, and they actually came and ended up talking to the driver there. And that's how they resolved their issue. Thank goodness that driver was ready to do that customer service activity. But that can be identified. And you think about that, you say, oh my goodness, there's lots of situations where I can change the experience for people, remove, what was ultimately a lot of panic and fear. If you think about that moment of, am I getting on the right train? You can remove that for your customers. The same is true of any traffic flow, the same as anywhere where right now, we might have digital signage, but what if the digital signage could know we had someone struggling right in front of it while it's happening? Think about what you could do there. Think about what could happen if that digital sign knew that all the cars down the way were full already because they didn't count occupancy.
Yeah.
Don't go any further. You're better off getting in right here. This is the best one with the most space for you. All of that exists, and yet again, we didn't just do images. We integrated it back into the operational, into the process of it all.
Right, and it's just the improved customer experience is what you've just delivered, isn't it, to that? Because
yeah, we took the nerd out of it, right? Again, I started off with all the nerd stuff, but that's not what it's about. It's about that customer experience, how happy that person is when they're finally sitting in that train seat, right? So that's what's going on. And you got to visualize it. You got to see, how do we put all this back together? How do we get it in places? Because, one of the themes we start off with is we don't want silos, right? The data, again, you talk about all those systems I integrated with. Security team never really cares what's going on with maybe one retail tenant, right? They care about if someone steals something, but these are different silos today for all intents and purposes. Maybe the management has a different interest. The folks who are renting out kiosks, there's so many people that, if we were to let each one of these IoT image solutions on their own, the data would be trapped and the value would be lost. So while they may have justified their investment, it really could have been a 1 + 1 = 3. We could have used that same image to let someone know there's a great customer coming. We could have used that same image to let someone know that there's, the door is broken, and use that exact same image to let someone else know that if we were to go out there and greet them, we could be sure that they were following all the safety protocols. Just think about that. One image, one solution. If you can serve 3 people, think about how you're really compounding that return on investment. It's kind of what I had to introduce today.
Yeah, that's interesting, because certainly we've seen it in the whole the retail space. We've seen it in transportation, in the airports, looking at possible new ways, to get revenue, and the idea of merging things together to know where people are, to link perhaps loyalty programs to the location in a retail environment, and that kind of thing. And I guess it leads nicely into our next session, which obviously we talk about asset tracking, and here you've got the guy in the buggy and the asset moving around. But yeah, that was fascinating, Aaron. So once again, many thanks for your time, and look forward to the next session on asset tracking.
Great. Thanks, Chris.